You know, when you pull up a map on your phone, ever stop to think what's really going on under the hood? We've come such a long way from those old, flat paper maps, the ones that just told you where stuff was. Today, maps are these living, breathing tools that can practically predict the future and help us make sense of our world. So, how'd we get here? Let's dive in and unlock the tech that made it all happen. Think about it. On one side, you've got that classic atlas. It's beautiful, sure, but it's totally frozen in time, right? It's just a snapshot. But then you have a GIS-powered map. GIS, by the way, stands for Geographic Information Systems. This thing is alive. It's interactive. It's packed with layers of data. And it goes so much deeper than just showing you where something is. It lets us ask the really interesting questions. Why is it there? And the big one, what if we change something? Okay, so what is this super-powered map tech exactly? Let's break it down and get right to the heart of what a geographic information system actually is. So at its most basic, GIS is a computer system designed to handle all sorts of geographic data. But here's the thing, it doesn't just store the info. Its real job is to collect it, check it, and then, this is the cool part, weave all these different data sets together. It's the tool that lets us see the invisible threads, the hidden patterns connecting everything out there in the real world. And that, right there, is the huge shift in thinking. We're not just looking at a simple picture of the world anymore. We're building an active, working model of it. It's less like a static photograph and way more like a digital twin of our planet, one you can poke and prod and ask questions of. Probably the best way to get your head around this is the layer cake analogy. Seriously, it's perfect. So you start with your base layer, right? That's just a simple map of an area. Then you start stacking other layers on top, like transparent sheets. The next layer could be all the roads and rivers. Then on top of that, you add another layer with all the towns and cities. And on top of that, maybe a layer showing population density, or even something like average income. See? Each layer is its own distinct set of data, but when you stack them all up, you get this incredibly rich, multidimensional view of a single place. Okay, so the data that makes up these layers, it pretty much comes in two main flavors. First up, you've got what's called vector data. Just think of it as anything with clear, defined boundaries. You know, stuff you can trace a line around, a single building, a road, the border of a park. Simple. Then there's raster data. This is for all the continuous stuff, things that don't have hard edges, like temperature or the elevation of a mountain. It's a lot more like a photograph, really. It's just a grid of pixels, and every single pixel has its own specific value. And check this out. This image from one of our sources really nails the difference. Now, don't worry about the Russian text on there. Just focus on the visuals. Over on the left, that's your continuous data. See how it looks kind of like a smooth hill? The values just blend into each other gradually. But on the right, you've got discrete data. It looks more like city blocks, right? Each zone has its own clear, separate value. A really powerful GIS has to use both of these to paint the full picture. All right, so we've got our data cake all layered up. But here's the thing, just stacking the layers isn't where the magic happens. The real power, the secret sauce, is in the analysis. This is the moment we stop just looking at the map and we start asking it questions. Which brings us to the big one. How does GIS actually turn all these separate layers into brand new insights? You know, how do you connect the dots between a layer of roads and, say, a layer of property values? Well, the answer is something called spatial analysis. This is all about understanding the relationships between the layers. You start asking questions like, how does this new road network affect population growth? You can ask these super complex questions and get the answers visualized right there on the map. Let's make this a bit more concrete with a real-world example. So, a team of researchers was studying a region in Russia, and they asked a classic what-if question. They said, okay, what if we improve the road network here? Where are people most likely to settle down and live? Now, your old paper map is totally useless for a question like that. But a GIS, it can actually model the answer for you. So here's what they did. First, they built a model. And in that model, they gave every single type of road a score or a weight. A big, paved highway, the kind that really drives development, that gets a high score, a 4. But a little dirt track or a footpath, that gets a teeny tiny score, like 0.1. They were basically translating the quality of the roads into simple numbers the computer could understand. Okay, so then they hit go and ran the analysis. And yeah, I know, the software in this screenshot looks like it's from the Stone Age, but don't let that fool you. The result it spit out is incredibly powerful.
What you're looking at is a brand new map showing settlement potential. The brighter the area, the more attractive it is for people to build and live there. And look at that. All of a sudden, you can see these bright corridors of opportunity just lighting up, following the paths of the best roads. The GIS didn't just draw a new map, it uncovered a hidden economic landscape that was invisible before.
And this is not some obscure academic exercise. This kind of analysis is happening all the time, in all sorts of critical fields. Take public safety. Police in London use GIS to pinpoint crime hotspots, which tells them exactly where they need to patrol. Or economic management. Officials in Russia paired GIS with satellite images to find illegal mining operations, which brought in millions in taxes that were just being lost. It's an absolutely essential tool for running a modern society. So when you have a tool this powerful, it's no surprise that it quickly becomes a matter of national strategy. I mean, to do this kind of high-level analysis for an entire country, you can't just have random bits of data. You need something massive, something coordinated. A single national foundation for all your geographic information. And that foundation has a name. It's called a National Spatial Data Infrastructure, or NSDI for short. Now, this isn't just one giant database in a government basement somewhere. Think of it more as a framework, a set of rules, standards, and policies that makes it possible for everyone, from different government agencies to businesses to universities, to share and use their geographic data together, seamlessly. It's basically the digital blueprint of an entire nation.
But here's the catch. Building one of these is a marathon, not a sprint. The US, for example, started laying the groundwork way back in the 1970s. It wasn't until 1994 that it became official federal policy. And from there, it's just kept growing, pulling in data from all sectors, until today, where it's this massive open access resource.
And this is where things get really interesting, because you see this big divide. On one side, you have countries like the US and the UK, who have these mature, deeply integrated data systems they've been building for decades. On the other side, you have a country like Russia. They started later, and they've really struggled. In fact, their system has been described as a fragmented information infrastructure. It really goes to show just how incredibly difficult it is to get this kind of national-level coordination right. And look, this isn't just some expert in a university pointing this out. This criticism came from the very top. Back in 2020, a high-ranking Russian official said, flat out, that their whole national strategy needed to be reworked because it was failing to solve the real-world problems their cities were facing. That's a pretty stunning admission, and it tells you just how high the stakes are. All right, so it's pretty clear that GIS is way, way more than just making pretty digital maps. It's really a new kind of intelligence, spatial intelligence, and it's fundamentally changing how we see the world. So let's wrap up with the key takeaways. So what are the big ideas to remember? 1. GIS turns old static maps into powerful, dynamic tools for analysis. 2. It all works by stacking layers of different kinds of data. 3. The real magic isn't just seeing the data. It's asking those deep why and what if questions. And 4. Nations are now in a serious race to build out the data infrastructure they need to unlock all this potential. And the reason any of this matters is because it's not just theory. This technology is being used right now, today, to make huge decisions. It's helping to decide where we build new schools and hospitals, how we manage our forests to prevent wildfires, and where businesses should invest to create new jobs. It is, without a doubt, one of the most fundamental tools we have for navigating our incredibly complex world. And that leaves us with one last big idea to think about. For basically the first time in human history, we are on the verge of having a complete digital map of, well, pretty much everything. So the new challenge isn't about finding more data. The real challenge is about us. It's about our own curiosity. The future isn't going to be shaped by the maps themselves, but by the quality, the creativity, and maybe even the audacity of the questions we choose to ask them.